Hello, everyone. We are Team Covcough, stand for COVID-19 cough detection. My name is Suns. I'm from Vietnam, and this is my teammate, San Tan.
Yep, I'm San Chan. I'm from Australia. Our project is aimed to pre-screen COVID-19 patients through smartphone recorded cough using artificial intelligence. And now we're going to go straight to the slides to talk about the projects.
In the middle of the COVID-19 outbreak in Vietnam, Dr. Sun started to work on a deep learning model that could help detect COVID-19 patients based on their coughing sample. When MIT released their publications about COVID-19 diagnosis using only cough recording and stated that their model identified 98.5% of cough from people confirmed with COVID-19, and of those, it accurately detected all of the asymptomatic cough. Due to this reason, we are eager to work on Covcough in hope that it will eventually be used to pre-screen patients in crowded settings. Today, the number of new cases in Vietnam reached 90,000 a day. It becomes very apparent that the frontline workers are overworked. There is not enough PCR tests to keep up with the rate of the virus spreading in our community. Not only that, the PCR test is costly for the government, very invasive, time-consuming for patients, which deters citizens from going into the clinic for testing. We need a quicker way and easier way to pre-screen patients. This is where we are hoping Covcough could help in the new normal. To use Covcough is quite simple. You just need to visit open.covcough.com on your browser, whether it's in your PC or your phone. Hit the record button and record the sound of your coughing, then send it to the server. The server will analyze your coughing voice using our model and return the result to you. Our data contain 1,000 samples from infected patients in Vietnam and 3,000 healthy individuals. To increase the number of samples and improve model generalizations, we also use another 500 recorded cough sample from the COVID crowdsourcing dataset published by the Nature journal. For validation data, we use 100 cough sample from Vietnamese individuals and another 100 from Indian individuals who were included in Koswara projects run by Indian Institute of Science. One of our biggest problems when we first started was the imbalanced datasheet that we have with only 1,000 samples of COVID-19 patients' cough compared to 3,000 healthy individual samples. To balance our data and further improve our model generalizations, we use several data augmentation techniques for audio to multiply our dataset. By the end of it, we were able to produce 300,000 coughing samples for training dataset and 78,000 samples for testing dataset and 1,000 samples for validation. For extracting features of the coughing samples, we tried several techniques, and by far the mass spectrogram proved to be the most accurate. We first built and trained our model on Google Colab and compared various AI model architecture. In comparisons, the residual network architecture provided us with the best outcome. Training residual network on Google Colab, however, was painfully slow, and the amount of RAM required was often more than the Google Colab Pro provided. The number of epochs we were able to train was only around 20. Due to the short amount of time we had to work with Habana Gaudi accelerator, we were not able to convert our code to use Horovod distributed training framework to train our model on all of the HPU core provided. However, because of the HPU speed was so fast, we were able to train our original model on a single core with 50 epochs in less than 3 hours. our team decided to make the most out of the instance we had and the credit provided to us by utilize the rest of the HPU to train 7 other residual network based off the original one with slightly different hyperparameters. This allows us to achieve a 90+% accuracy. Finally, the technology behind Covcough is very simple. We wanted it to have the least moving part, scalable, and most importantly, affordable. This is because we are a team of 2 with very limited budgets for the side projects. For the static component, the HTML, JS, and CSS live in the GitHub page. The only dynamic codes are the 2 Lambda functions behind an API gateway. The API handle Lambda function is responsible to receive and respond to requests for file upload and file download from our S3 bucket. This API will then generate a signed URL to our S3 bucket for our web application to complete the task. This cut down the need to build code for handling upload, download file ourselves and reduce the attack vectors. When coughing sample is uploaded to our S3 bucket, another Lambda job is triggered to analyze the coughing sound based on the model that was previously trained by the Habana EC2 instance. This returns the result image back to our S3 bucket, where the user browser is polling for the result with the signed URL it previously received from our API Lambda function. This design let us run the entire Covcough applications on AWS with less than $2 a month and serve thousands of patients a day at peak with no issues.
So thank you very much for your listening to our projects. And we are hoping to improve the training model with the help of Habana Goldie accelerators in the future with the credits we may be awarded from these competitions. So thank you so much.
Thank you very much.